Chapter 1 Season X was easily the most controversial season in Fortnite history, and that is due to mainly one thing: the brute mechs. Pretty much everyone hated them because of how blatantly overpowered they were, especially at the start of the season. If you were going up against someone and they were in a mech, unless they were literally the worst player in the world, you were guaranteed to lose that encounter. Things got so bad that #RemoveTheMech began trending on Twitter. In response to the backlash, Epic Games made a blog post where they basically said that they were not going to remove the mech because they believe Fortnite should be a game where anyone can win. Alongside this, they posted a graph showing how many kills per game are gained from mechs. Most people were highly skeptical of this graph. Only 4 mech kills per solo game? That didn't seem right. This graph brought one YouTuber who I regularly watch, HJ Dugan, to do some investigation of his own, which brings me to the topic of this video. Using actual statistical math, I will be comparing the results that Dugan got to the official graph posted by Epic to see if we have convincing evidence that they were lying to us. So without further ado, let's get into it. Before actually getting into the math, there's a couple things we need to go over. First off, my credentials. Some of you are probably wondering if I'm even qualified to make this video, and let me just say that I am more than qualified to be doing this. Why? Well, I'm currently in a ProbStat class. That's something, right? Second, and this is mainly for content purposes and to line it up with the stat problems that I do in class, I will be formatting this as if it were a statistical word problem. You'll see what I mean when I get there. Finally, when Dugan did his testing, he got himself killed by a mech and counted it as a mech kill. Additionally, he speculated some kills to be from mechs when they were not explicitly stated to be in the kill feed. In order to eliminate some bias, I will not be counting him or the non-brute specified kills in the data. And that's pretty much everything I need to go over before starting. So now, let's actually start. Epic Games claims that brutes account for 4 eliminations per match. Whenever Sir Dugan is playing, it seems that far more people are getting eliminated by brutes. To investigate, he played 4 matches and recorded how many times someone was eliminated by a brute. Here is the data: 3, 5, 7, 6. Does this data give convincing evidence that the number of brute eliminations per game is higher than expected on average? For standard statistical problems, we typically follow a 4-step procedure, and the first step is the state step. State. Now, the first thing that we do in this step is we have to identify our null and alternative hypothesis. Let me get a different color real quick. Our null hypothesis, or HO, is mu equals 4. Where mu is equal to the true mean number of brute eliminations per game. Excuse my sloppy handwriting, I suck at writing with a mouse. The next thing we need to determine is our alternative hypothesis, or HA. HA is essentially what our belief is, and in this scenario, we believe that mu is greater than 4. That's a really bad 4. Hold on. 4. There we go. The next thing that we need to do is find our significance level, or in this case, alpha. Since alpha is not stated anywhere in the problem, we can assume that alpha is equivalent to 0.05. 0.05. Let me fix that. Or in other words, 5%. The last thing that we need in this step is evidence that our claim is true. Now, if we take the mean of 3, 5, 7, and 6 added up together, we can see that x bar, which is what our mean is, our sample mean, x bar is equal to 5.25, which, as most of you would probably know, is greater than 4, meaning that we have at least some evidence that our claim is true. The next step of a statistical word problem is the planning step. So since this is a means problem, we will be using a 1-sample t-test for mu. Before moving on though, we need to check that our sample is both random and normal. An argument can be made that our sample was not random because Dugan played 4 matches in a row. However, I have a counter argument. This sample was taken before Epic Games added skill-based matchmaking to the game, meaning that each game played has a random sample of players, making our sample, in fact, random. Let me go ahead and add that check mark. Yes, random. Next up is whether or not the sample is normally distributed. It is not stated anywhere in the problem that the sample is normally distributed, and our sample size does not meet the law of large counts. And for those unfamiliar, the law of large counts states that, let me get a different color real quick though first. The law of large counts states that if n is greater than or equal to 30, then you have a normal sample. And for the unfamiliar, n is just equivalent to your sample size. Since neither of these are met, our only metric of seeing whether or not it's normal is by graphing it. From the box plot that I've put on screen, you can see that we do in fact have a normal distribution, so we are free to proceed. Step 3 of a statistical word problem is the do step. For this step, we need to find the sample statistic, the standardized test statistic, and the p-value. The sample statistic is pretty easy. That's just x bar, so let me real quick just remind you all. X bar is equal to 5.25. The last two things we need to find through calculation. Normally I would use a TI Inspire to put our data into a list and calculate these things, but I don't have an Inspire of my own, so I have to use the next best thing, an online calculator. So we just put our data here, and then we put our hypothesized mean here, and then we click calculate, and oh, I wasn't expecting that. From the calculator, we found that our standardized test statistic, or T in this case, is equal to 1.464. Actually, that's a really bad 6. Let me fix it, and now it looks fine. Additionally, we found that our p-value is equal to 0.1197. The final step of a statistical problem is the conclude step. As previously stated, our p-value is equal to 0.1197. Compared to our significance level alpha, which is equal to 0.05, our p-value is actually greater than alpha. So in a shocking turn of events, we fail to reject HO because we do not have convincing evidence that the true mean number of brute kills is less than 4, something that absolutely nobody expected. Out of curiosity, I decided to do 3 more tests. One where I included the people killed by falling, one where I included Dugan's deaths, and one where I included both. And the only ones that provided convincing evidence of our claim were the ones with Dugan included. I truly cannot believe that there is evidence that Epic didn't lie about the mechs. I thought for sure that there would be drastic evidence that way more than 4 people died to mechs per game, but I guess we were wrong. I have a feeling that that's to do with one thing, the sample size that we had. If we would have had more than 4 games to test our claim, maybe we would have had evidence, but as it stands now, we were wrong. Anyways, that's it for this video. I had a lot of fun making this, and I hope you enjoyed watching it too. See ya.